Okay, so we are in quarter 2, week 8, and this week we are going to be given a quadratic equation that is in vertex form. We talked about the vertex being the highest or the lowest point on a parabola curve. And so now we're going to be looking at an equation, and you are going to be telling what the vertex is and then possibly matching the graph. So first, let's go over what the equation is going to look like. So the vertex form of a quadratic equation is going to be in this form, okay? And so instead of f of x, that's function notation. You could see the equation with y. It means the same thing. And there are 3 numbers that have special meaning in this equation. So the y we're going to kind of ignore. The equals we can ignore. The parenthesis, the x, and then this squared. All of those are going to be the same for every equation. The numbers that we want to look at that mean something are the number in front, which is an a, okay? And so we're going to write down what the rules are. So if a is positive, then what that means is your graph is going to open up, okay? And so you can just tell by looking at the equation if it's positive or negative. If the equation is a negative number, that means that our parabola will be upside down, okay? And so that dictates how it opens, okay? We look in front of the parenthesis, okay? All right. So the last third number is the number outside the parenthesis at the end, and we let that be denoted with a K. Now, this K, because the formula has a plus, positive, we want to use the same for the y value of the vertex. And once again, because it's a y value, that typically moves up and down. So we'll use those words, okay? So we can describe how the graph moves. We can give the actual ordered pair of the vertex. There's a lot of different things we can find, but they all really are related. All right, so let's look at kind of an example. So we're going to be given this equation, and it's going to say, describe how the vertex moves. So first, we want to answer those 3 things, because that will help either match a graph or describe the motion, things like that. So let's see how it opens. So I want to look in front, and when there's not a number there, we can let that be a 1, and by default it's positive. So because the number in front is positive, we know that the graph opens up. So it opens this way. So if we were matching a graph, we'd be able to eliminate some, okay? Now, let's talk about the vertex specifically. So in green, we're going to use the rule. We want to use the opposite number for the x value of the vertex. So this is the number we want to use the opposite for. So our vertex, the x value, since the equation has positive 5, our vertex is going to be the opposite, which is negative 5. And so negatives go to the left. So we would say left 5 units. Okay? And then the y value, that's in purple. It says we want to use the same number for the y value. So let's look at our equation. And so it's the number outside the parenthesis at the end. And since we have negative 1, that's going to be the same number for the y value, because this was x and this was y. It's like alphabetical order, so it's easy to remember. And so y goes up and down. Since we have negative 1 for the vertex, negatives go down. So we would say down 1. Now, if we were matching a graph, I would want to know that, oh, left 5, down 1. The graph that I would match it with is going to look like what we're going to draw. So 1, 2, 3, 4, 5, and down 1. That would be our vertex. And we knew it opened up. So I would want to find the graph that matched that, okay? So we can either describe how the vertex moves, or we could match the graph. All right? So let's try a couple more. All right, so this is what one of your practice activities is going to look like. We've got 3 equations, and it says identify the vertex and then match each equation with its graph. And so I'm going to let this be like A, B, C, D, E, F. Okay. All right, so let's look at our first equation. So we really do want to pull out how our graph moves and what our vertex is. So on this one, we know A is 1 because there's not a number here. So I know it's going to be a graph that opens up. So we can already eliminate F, and that's it. Okay, so I'll go ahead and cover that up with my video. So now I need to actually find the vertex. So we want for the X value, I want to do the opposite number. So we're going to write -2, which means we're going to go left 2. And then the Y value is the same as what's on the equation. So -5, and remember Y is up and down, and so we're going to go down 5. So I want to start always at 0, 0, where the axes cross, and we want to figure out which one goes to the left 2 and down 5. So that one goes to the right and down. This one goes to the right. This one only goes up. This one goes to the left 2 and down 5. And so we want to match D with A. Okay? All right, let's look at the second equation. So this one, we know A is 2, which is positive, and so our graph opens up. So once again, we're not looking at F, and we're not looking at D. Okay, so we've got A, B, C, or E. So let's find our vertex. So our vertex, the opposite would be +1, and so positives go to the right. And then the number at the end is +3, and so positives go up. So we'll go up 3. So we want to know which graph does the vertex go to the right 1 and up 3. It looks like it's B. All right. The last equation we match, the number in front is A. This one looks a little different because there is no parentheses. So sometimes what you can do is if I add a parenthesis with the X, I can always put a 0 with it. Now, you don't have to. So if there isn't a parenthesis, what that really means is it doesn't move left or right. So it goes 0 left or right, which means it's going to stay on that y-axis. And the number at the end is +4, and so we know we're going to go up 4. This negative in front is A, it's like a -1, and so we know our graph is going to open down. So we only had one graph. Go ahead and move my video. And that one opens down, and look, we don't go left or right, but we do go up 4, and so that does match, okay? And so sometimes if you don't have a number at the end, you can add a 0, but if you don't have a number in parentheses, you can add a 0. It means it doesn't move left or right, okay? All right, let's try a couple more and just describe how the vertex moves. So on number 1, A is 1, and so we know the graph, if we're graphing this, would open up. Once again, I don't have a parenthesis, so that means there's no number for the left and right, so 0. And then the number at the end, because it's not in a parenthesis, that's the y value, so we keep it the same. And so we want to go down 4. So we would do none left and right, and down 4, and this would be our vertex, 0, -4. Okay, they kind of go hand in hand. All right, equation number 2. Well, it looks like A is positive, so we know our graph would open up. We want to use the opposite of the number for X, so negatives go to the left, 2. We don't say left -2 because that's kind of counterproductive, all right? And then the number at the end is positive 1. And so since that's positive, we would say up 1, because one of your activities you have to describe the direction and the amount. All right, let's look at number 3. So example 3, once again, g of x is just the name of the function. If that confuses you, you can always let it be y. So the number in front is negative, which means my graph is going to open down. Okay? There's no number in the parentheses, so I know that that is 0 left and right, so there's none. And then the number at the end, that's the same as the y value, and since that's positive, we would go up 9. Okay? All right, example number 4. Well, the number in front is positive, so I know that's going to open up. And so the vertex, we're going to use the opposite number, so positive 3, and since that's x, positives go to the right. And the y value is the same, so we'll keep that at negative 2, and y goes up and down, and so we're looking at down 2. All right, and our last example, number 5, we know a is positive, so our graph opens up. Our vertex, we're going to use the opposite x value, so positive 1, so positives go to the right. And we keep the number the same, so negative 3, and in the y direction, negatives are down. Okay? All right, there's a couple more, but none of them are different. So even if we had a fraction, remember, we're just looking to see if it's positive for how it opens. And same thing, if we could have a number there, if that's negative, it still opens down, okay? All right.